A2.
Okay, so the first thing we need to do to calculate the concentration of ibuprofen is that we need to find out the molecular mass of ibuprofen. So first thing we need to understand about the chemical formula of ibuprofen. Here on the Chinese pharmacopoeia, there is something written here, which is the molecular mass of ibuprofen, which is 206.28. So we record that. The chemical formula of ibuprofen is C13H18O2, which is 206.28 gram per mole. Okay, so this is the molecular mass of ibuprofen. So next, let's justify two things. The first thing is the chemical formula between ibuprofen and sodium hydroxide. So between the ibuprofen and sodium hydroxide, their proportion should be 1 and 1. It should be proportional, so it's C13H17NaO2 plus H2O. So they are 1 proportion to 1. So hence, for the first circumstance, we use 5.6 milliliter of 0.1 mole NaOH solution, and for second circumstance we use 5.2 milliliter of 0.1 mole of NaOH, and in this case we can get the mole of NaOH we use, which is 0.1 mole per dm cube times 5.6 milliliter times 10 to the power of -3, and this one should be times 5.2 milliliter times 10 to the power of -3, and each of them should be equals to 5.6 times 10 to the power of -4 mole, and this is 4.2 times 10 to the power of -4 mole. So both of them are both for NaOH and for ibuprofen. And so now we can calculate the gram of ibuprofen using its molecular mass. So here we use 206.28 copmole times 5.6 times 10 to the power of -4 mole to get its grams, which is 0.116 gram, and for another it should be 0.107 gram. So for these two circumstances, we know that we use 0.5 gram, so we use this to over 0.5 gram of our chemical, and it should be 23.2%, and other one should be 21.4%. This is for the first circumstance, second circumstance. So we now go to measure the mass of the whole bag of our chemical. So I have poured the whole bag of chemical on the balance, and it shows 0.9925 gram of one bag of ibuprofen. 99 gram. So we use 0.5 gram over 0.99 gram. It's also approximately 0.5, which is 50%. And there's a difference between these two numbers. That means there's an error in my experiment, which I will find out later. But you can see the difference between the first circumstance and the second circumstance. This means the different expiry date can lead to a different concentration of drugs, and also concentration. So it also leads to a conclusion that's of my experiment, which is the one has longer expiry dates has a lower concentration. So today we have processed the data, and during the process of processing the data, I find several things which is very interesting. The first thing is I can not only use the method that the school teacher taught me. In Chinese Pharmacopoeia, there's one method of calculating the concentration of ibuprofen, which is also already given here. That means every milliliter of sodium hydroxide titrant is equals to 20.63 milligrams of ibuprofen. It has already calculated for you. You can just use that data. This is what I've learned, the first thing. The second thing is the measuring of the whole bag of ibuprofen needs more modification. And I also see the real estimation, like my hypothesis has been proved, and that's what makes me very excited and very amazed. The last thing, but not the least, is that my experiment has been hypothesized well, and the conclusion has demonstrated my hypothesis. I'm so satisfied with this, and this is what I've learned during day 2. And thanks for watching, and looking forward to the next episode.